Hello guys, welcome to week 10 video tutorial. In this video, I'm going to discuss how you could create the RESTful web service from scratch with Spring Boot running in Docker container. Firstly, before we create our project, we need to set up our environment to work for our project, including Docker as our application container, Postman to test our API, Maven and IntelliJ as our IDE. Go to your web browser and open this page. Download and install those installation packages. For Maven, you will need to use command line installation. As a Mac user, I would just directly use brew to install the Maven. However, if you don't have the Homebrew installed in your system, please type this command to install Homebrew first. After you install the Homebrew, just type brew install Maven to install the Maven package. Once you've set up everything correctly, let's check our environment by typing maven -- version to check out Maven, docker -v to check the Docker, and docker -compose -- version to check the Docker compose command. Now, if you can see the same result as I do, you are ready to go. Since we have already set up our environment, let's create our project. First and foremost, create a new folder to hold all the project files. In my case, I would name it as demo. Next, open the IntelliJ and hit create new project button. Choose Spring Initializer and hit next. Here, let's put org.fit5042 in group section and put Pokemon in artifact section. The artifact represents the project ID. Later on, when we build the project jar file, it will be named based on this ID. Next, follow as the default settings for the dependencies. Let's change our project location into the folder that we've just created. After we successfully created the project, we should be able to see this file structure inside our project. The first thing we need to do here is to modify our pom.xml file. Basically, all the required dependencies of the project will be added into the POM file. Here, we need to add two properties in the properties tag. Additionally, we also need Spring Data JPA, Spring Web, and MySQL JDBC connector. Let's copy the code from the specification to the corresponding places. Since we are using Spring Boot instead of Spring MVC, we just need to have a control class, an entity class, and a repository interface. Go to the root package and create a Pokemon controller inside the controller package, Pokemon inside the entity package, and Pokemon repository under the repository package. After this, you should be able to see this class structure as showing on the screen. You might notice the Pokemon application. This is the main class of our application. If we inspect this class, it only contains the main method in order to run our application. Before we do the actual coding, let's build our application first to generate our jar file and install all dependencies so that we can avoid some importing issues. Type the instruction for maven clean install -d maven.test.skip equals true to enable Maven to build the project without testing. Now we can see a new folder called target has been generated. When we inspect this folder, we can see that there is a jar file inside this folder. The name starts with the artifact ID, as I mentioned before, and followed by the version. This jar file will be mapped to the Docker to let Docker create an image and run it in the container. Let's go to Pokemon entity class and copy the code from the specification. There will be some errors when you first paste the code. Move your mouse over the entity annotation and click the solution provided by IntelliJ to solve the issue. Since the ID is auto-generated, we don't need to worry about this attribute when we send the post or put request to the web service. Now let's navigate to our Pokemon repository interface. Copy and paste the code from the document. As you might notice, the beauty of using Spring Boot is that we don't need to implement the logic of the CRUD function. These are handled by the JPA repository. In EJB, we have to implement our own CRUD logics, whereas in Spring Boot, we just need to inheritance from the JPA dependencies and provide model as well as the ID. Next, copy the code to the controller class. In this class, it will handle all the HTTP requests and map them to the corresponding JPA transaction. We use request mapping at the top of the class to declare the base URL, and inside we use post mapping, get mapping, put mapping, and delete mapping for handling different HTTP requests. As you have noticed, we can also use request mapping annotations to implement these methods. The main advantage of using request mapping is that it gives us more controls. We can set the root in the value property and request type in the method attribute. The last thing for our application is to configure the variables of our database. Go to the application.properties file, which is located inside the resources folder, As you can see, here we declare the database URL, username, and password. Based on the URL, you will notice that the database name would be Spring App DB, and both the username and the password are FIT5042. Hence, later on, when we set the environment variables for our Docker container, we will use the same value for these database properties. After finishing the above steps, let's run maven clean and install again without testing, since we haven't had the actual database running yet. Basically, we need the latest jar file including all the database connection properties to be ready for creating our Docker image. Speaking of the Docker, let's create a Docker compose YAML file. Copy and paste the code inside this YAML. Basically, the structure of YAML file is like a JSON file. Let's inspect this YAML file first. There are two services inside this file. One is for the database container and the other one is for our application container. In the database container, we tell Docker to use the latest version of MySQL, and we set the environment variables as same as the values we set in the application properties file. Volumes is for holding the persistent data on our hard disk. Here we use same network for both our database and application to enable them to connect on the same network. When we look at the Spring Boot app, we map the external port 8087 to the internal port 8080. This means when we call our API, we have to use port 8087 instead of 8080, because 8080 is the port inside the container, whereas 8087 is for the host. Finally, we declare my network inside the networks. Since we haven't put anything, it will just use default setting. Now, the last step we need to do is to create a Docker file. This file contains all the necessary commands to build our image and run it into the container. Let's build and run our app in the Docker container by calling docker-compose build to let the Docker build the image for us. Then type docker-compose up to run image. Seems that our application is running perfectly. Last but not least, let's test our Pokemon API using Postman. Here in the URL, remember we need to access the port 8087 and the root URL is API followed by Pokemon. Since our database is empty, let's try to create some Pokemons by calling post method. We can also update the existing Pokemon by calling put method. Here, we also need to specify the ID in the URL. Finally, let's try to remove the first Pokemon by delete method. After the testing, we can tell that our API works perfectly fine. The beauty of using Spring Boot to build this web service and using Docker is that we don't need to consider different running environments, and the CRUD functions can be used for any application. And we don't even need to worry about the implementation of the CRUD since Spring has already handled everything for us. So far, we have successfully completed this project. Hope you will enjoy this video and we wish the content could be helpful for your assignment and the exam.